All right, guys, so here's yet another practice problem from our notes. This time, instead of looking at changes in potential energy, we'll look at changes in kinetic energy. So here we have a 1,000 kilogram car. Its engine does 1,500 joules of work. So this is what the amount of work the engine is doing to get the car up to a speed of 15 meters per second from rest. And we want to calculate what is the efficiency of the engine. So as always, I've drawn a diagram just to kind of keep all of my numbers straight. I've drawn my before and after. I've included the mass of the car, the starting velocity, the final velocity, and because we are dealing with efficiency, I've already tried to figure out, well, what is going to be my kinetic energy change. Okay? So right off the bat, I know that the initial kinetic energy of my car before, it has to be zero, right? Because our kinetic energy equation all depends on velocity. If you don't have motion, you don't have kinetic energy. So our starting is pretty easy to calculate, right? Now we just got to figure out the final kinetic energy. So we'll take the mass times half, multiply that by the velocity squared. You should have gotten a kinetic energy, a final kinetic energy of 112,500 joules. Okay, so I've labeled that here. So the change in energy, right, the amount of work that was actually accomplished. Okay, this is what we got out of the whole process. The change in energy from 0 to 112,500 okay, is, of course, 1,112. So the energy that we got out of the system is that value there. Okay, and we are going to compare that to the amount of energy that we put into the system. Okay, what did the car contribute to this system? And it did tell us in the question. So the car put in 150,000 joules of energy, but it only got out 112,500 joules, right? So a little bit less. And this should make sense, right? Because no machine is going to put out more energy than what you put into it, right? Because we're always going to lose just a teeny tiny bit. So if we want to calculate the efficiency of the engine, don't forget that efficiency is equal to the energy out divided by the energy in, multiply that by 100. Okay, so we can just take the energy out divided by the energy in and multiply that by 100%, and to calculate that efficiency. So 112,500 divided by 150,000. Okay, multiply that by 100%, and I'm getting 75%. So my efficiency, the efficiency of this engine, is equal to 75%. Okay, so again, when identifying the efficiency of any type of problem, look at, well, what was the starting energy before? What was the final energy, depending on that change? That's what we got out of it. Okay, that's what was actually accomplished. Then we want to compare that to how much we put into it. And again, it should never be more than 100%, because that just is physically impossible. So if you guys have any questions, please let us know, and hopefully this is helpful. Thanks.